Congruency is a concept that suggests that triangles are the same or rather equal at certain conditions. Today we're going to be looking at congruency and its conditions. Welcome to Edu-ca-te. Thank you for staying tuned, and let us look at the first condition that gives us a right to say that two triangles are congruent. Okay, so we have got these two triangles. Well, they may look like they're not congruent. They may look like the other one is bigger, the other one is smaller, but then the values of their length will actually tell you that this is smaller and this is bigger, not just speculation by the human eye. So here we're going to look at the first condition in which we can say that triangles are congruent. So triangles are congruent when this side here for this triangle, let's name this triangle A, B, C, and then let's name this P, Q, R. So we've got triangle ABC and we've got triangle PQR. These are two different triangles. So to be able to prove that they're actually congruent or they are the same or rather equal, so it means that you have to prove that side AB is equals to side PQ. So when this side here becomes 70, this one also becomes 70. That makes those two triangles congruent, but then that's not enough as of yet, because this other side might not actually prove to you that these triangles are actually equal to each other. So the other sides, this one and this one, must also correspond. In that way, BC will be equals to 60 and also QR will be equals to 60. So if you are able to prove that BC is equals to QR and they're all equals to 60, then it means those two triangles that contributes to their congruency. But then we're not done. The third marking we're gonna use here is this here, this side and this side are equal. So the base sides are actually equal. If you can see the base of this shape, which is AC, base AC must be equal to base PR. So these are the two bases of our two triangles, that's AC and PR respectively. So here, if we are able to prove that this side AB is equals to side PQ, and then if you're able to prove again that BC is equal to QR, and then if you're able to prove that AC is equals to PR, then you have a right to say that the triangles are congruent to each other or they are equal to each other. So let's look at condition 2 of proving that triangles are congruent. So the second condition for proving that for proving congruency, it means that we have got A, B, C here, and then P, Q, R. So if we are able to prove that side AB is equal to side PQ, therefore that contributes to their congruence. But then we're not done yet. We need at least 3 things to prove congruency. This is a triangle, meaning that we have to get at least 3 things so that we can actually prove that the two triangles are congruent to one another. So if AB is equals to PQ, by that I'm talking about this AB and then this PQ, and then if QR, which is this side, is equal to BC, so these are equal. So, and then the angle which is subtended by those known sides here at B, and the angle here on top again is what? If those two angles are equal as well, then it means you have already proven congruency of these two triangles. So supposedly here it's 80, here also must be 80, and then here is 70, here also must be also 70, and then if this one is 90 degrees, also here it must be 90 degrees. So if we are able to prove those 3 things, you can therefore say that the congruency of triangles there is actually visible. That doesn't mean that this side is going to be equal to this side. No, that was the first condition of proving congruency. Now we go to the third one. So the third condition of proving congruency is if you have got this side corresponding to this side. So you've got side AB corresponding to side PQ. So you have got AB, this is marked with blue here, which is equal to PQ. You can see that those sides, if they are equal, that contributes to their congruency as well. So if you also have an angle here equal to an angle here on top as well. Remember, the position of an angle is so important in proving congruency. So if this angle here is equal to that angle over there, that can also contributes to congruency. But then because we know that we need three things to prove congruency, therefore the third thing is if you have an angle here, let's name this angle X, and then this angle X as well. So if this angle here at the base and then this angle here at the base, at that position, you can see that these two are corresponding, this angle X here and angle X there. Those two are corresponding, but then in two different triangles. Therefore, if you're able to prove those three things, you can therefore say that triangle ABC is congruent to triangle PQR. So if this is 80, this also ought to be 80, and then this one 70, this one also must be 70. If this one is 20, this one also must be 20 degrees. So that makes these two triangles congruent. And then let's go to the last condition of proving congruency. So this condition applies when you have got two right angle triangles. So here let me indicate that this is a 90 degrees angle. So we're having our ABC and then we're having our PQR respectively. So here, having these two triangles, we want to actually prove that they are congruent. So this is the only condition for proving right angle triangles. So here, if this side, which is the vertical side of one triangle, is equal to the vertical side of the other triangle, that contributes to congruency. And then the second thing is if this side, which is the hypotenuse, is also equal to the hypotenuse of the other triangle, that also contributes to proving the congruency of two right angle triangles. So here, remember that we said we need three things. Well, I'm not going to say that AC is equals to PR, not at all. We already have a 90 degrees angle here and a 90 degrees angle there. That shows that they have something in common. They've got a 90 degrees at this corner and they also have a 90 degrees at that one. And this vertical side is equals to the vertical side of the other triangle, whilst their hypotenuses are equal to each other. So here we can say if we have got 80 here, this is supposed to be 80 as well. If we have got 75 here, this also got to be 75. I don't mean that these values are realistic. I'm just laying out to show you what I mean by equal sides. So here, if we have got 90 degrees, here also must be equal to 90 degrees. So to be able to prove the congruency of a right angle triangle, you have to prove that the hypotenuse and the side of the one triangle is equal to the hypotenuse and the side of the other triangles. So for this triangle, you have to prove that AB is equal to QP. You can also prove that QR is also equal to BC. Therefore, you would have proven your congruency of right-angled triangles. Thank you for watching. Don't forget to subscribe. Don't forget to watch our next video as we'll go further in Euclidean geometry. Thank you for watching.